Hello students. Before we continue looking at the Pythagorean theorem in more detail, we've got one more topic that we need to discuss, and that is square numbers and square roots. So square numbers, well, 1 squared just means 1 times 1, or 1 squared, and that just equals 1. 2 squared is 2 times 2, or 4. 3 squared is 3 times 3, or 9. 4 squared is 4 times 4, or 16, and so on. And in this table, we go all the way up to 20 squared, which is 20 times 20, or 400. So what I think you should do now is stop the video, copy out the table, complete the table, and then learn the first 20 squares, because you'll be using them in every single question that you do with the Pythagorean theorem. Now, the inverse operation of squaring something is taking the square root. So, for example, the square root of 1 is what number times itself gives us 1, which is 1. The square root of 4, what number times itself gives you 4? Well, that's 2, because 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. The next one is going to be 5. 5 times 5 is 25. So therefore the square root of 25 is 5, and so on. So once again, my suggestion is stop the video, copy out the table, and just write out the first 16 perfect squares. Now, of course, not every square root works out nicely like that. So for example, what if we have the square root of 3? Well, if I look at my calculator and type in the square root of 3, I get a very long decimal. And in fact, that decimal goes on forever without repeating. That's an example of one of the irrational numbers that we looked at in the last video. So if you look at the first 3 decimal places, 1.732, I want to round that back to 2 decimal places. Now the way I do that, just as a quick reminder, is I actually have to decide whether the 3 stays as a 3 in the second decimal place or rounds up to a 4. And I decide that by looking at the next digit, which is the 2. So let me just change my pen color back again. So we say if that number there in the third decimal place is 5 or bigger, then that rounds up to a 3. Otherwise, rounds up to a 4. Otherwise, it stays as a 3. So in this case, it's 1.7. Because that's only a 2, the 3 stays as a 3, and that's correctly rounded to 2 decimal places. Okay, let's try the square root of 19 together. So I'll clear that on my calculator. And the square root of 19 is 4.35889, etc. So because I'm rounding to 3 decimal places, I need to look at it to 4 decimal places. So 4.3588. So does that 8 stay as an 8, or does it round up to a 9? Well, I look at the next decimal place. Because that's 5 or bigger, that's going to round up to a 9. So it's going to be 4.359. And that is the square root of 19 correctly rounded to 3 decimal places. Okay, stop the video, and I'd like you to round each of the remaining 3 square roots to the number of decimal places shown in the brackets. Okay, so stop the video and turn it back on and check your answers. Okay, welcome back, students. Well, let's quickly go through these. So first I need square root of 8, and I need that rounded to 3 decimal places. So 2.828 Now, because the decimal of the number in the fourth decimal place is a 4, that stays as 2.828. Okay, looking at the square root of 5. Now we're going to round to 2 decimal places. So it's 2.23. Now the next decimal place is a 6, so the 3 rounds up to a 4, giving me 2.24. And the last one, the number inside the square root this time is a decimal, but that's fine. That's no more difficult when you have a calculator. Square root of 6.75. And this one we're rounding to 2 decimal places. So I get 2.59. And the decimal, so the digit in the third decimal place is an 8. So that 59 has to round up to a 60. So 2.60. And there we have it. So that's squares and square roots. Very, very important when you're studying the theorem of Pythagoras, because you'll use them again in every single question. So in the next video, we can actually start to learn more about what the theorem of Pythagoras actually is.